So, welcome to Sundar's lecture. This is lecture number 12. So, this is lecture number 12. And in this lecture, we will take a new topic, nodal voltage analysis method. Again, we are going to get what is the current in each resistor. That is not an issue here. Anyhow, we are going to solve this problem with a different technique now. Right. Now, this is nodal voltage analysis method. Then you should know what is a node, that we have seen in our previous classes. Node, which is nothing but it is a common point where three or more branches connected at a particular junction, and that junction we will call it as node, right? So you see how many nodes are available in this circuit. First you need to find how many nodes are available in this circuit. See this one, this is one node. See, there are three branches connecting at a junction. So what you do, you assume this as A. Let it be A or 1 or 2. That depends on whatever the denotions you are taking. So you see again this point, there are three branches again. 1, 2, 3 branches are connecting. So what you do, you just assume this as B. Maybe you put 1, 2 also. That will help us while writing the expression. This is 1 and this is 2. And now you see here also there is 3 point connecting. This is one, and this is one. And in this point also there are 3 point connections. And if you want to say, and you see one thing you have to understand, this is not a different node and this is not a different node. Both are same, since you see if you are taking this as one node and this as another node, and between these two nodes there should be any resistor or voltage element should be connected. If it is not so, then these two are same nodes, right? There is, if there is no elements connected between any two nodes, any two points where three branches are connected, then you consider both as same node, right? So now you see, you see every negatives or these points are connecting at the same end. So what I will do, I will say this is reference node. I'm not going to consider this node into account. If you ask me how many nodes are there in this circuit, there are two nodes. One is A and one is B with respect to this reference node. Always you say this. You have to take any one node as a reference node. That it may be this or this. This can be also considered as reference node. That is up to you. Again, that is up to you. You see, because this is a common point to all the negatives, so I will consider this as a reference node. Reference node can be assumed by us, no problem, right? So now you see, I am going to solve this problem using matrix method. And I am going to write the matrix form. You see what is I? So I will write like this. What is I now? I will be equal to, right, I will write the formula first. I will be equal to V by R. That we know, right? I will be equal to V by R. So how I can write this expression? I will be equal to 1 by R into V. Right. Now how I can go further in this expression? I can write I is equal to G into V. What is G? G G is nothing but conductance. G, which is nothing but what? Conductance, right? Conductance in inverse of resistance. So I expression can be written as G into V. Now you come here. What we can do? Matrix G with multiplied with matrix V will give you what? Matrix I. We have written already, right? There we have written for voltage. Here we are writing it for current. Right? This is conductance matrix. This is voltage matrix. This is current matrix. And now you see, we are going to find what is the voltage in this node with respect to this reference node. Right? With respect to this reference node, you can write it as 0, O or 0, O, anything it may be. But what is the thing we are going to find? We need to find what is V with respect to O, what is B with respect to O. So what we need to find, VAO and VBO to be found. If you find what is VAO and what is VBO, then we can easily find what is the current in all the resistors. Current in all the resistors can be found using these two voltages, right? Now you come here. This G matrix will depend on how many nodes you have. How many nodes you have here? Two nodes. Then obviously this G matrix will be 2 cross 2 matrix. Obviously this G matrix will be 2 cross 2 matrix. That we have already seen anyhow. So this is G11, G12, G21, and this will be G22. And as we said already, all off diagonal elements will be minus. All of diagonal elements will be minus and diagonal elements will be positive. Then this V matrix will be a single column matrix again. VAO, VBO. That we need to find what is the first node voltage, what is the second node voltage, right? Now, this should be equal to IA and IB. This should be equal to IA and IB. What is the current in node A? What is the current in node B? That you need to find here, right? So now we try to write the matrix form. Here you try to understand. We need to write what is conductance, but we have only what? Resistor. Then you inverse this. Inverse those resistors to get the conductance. What is G11? What are all the resistors connected in the first node? That not resistor, we need to convert it into conductance. That we will see, but I will tell it as resistor. See, 2 ohms resistor is connected, 1 ohms resistor is connected, 3 ohms resistor is connected. Then what you do, you try to write 1 by 2, put a bracket, 1 by 2 plus 1 by 1 plus 1 by 3. These three resistors are connected in the A node. That I have converted into conductance. 1 by resistor. 1 by resistor will be conductance, right? Now you see G12. G12 means first node and second node. What is the common resistance between first node and second node? You see, if you take this as your A node, then this 3 ohms resistance is connected to this node. As well as this 3 ohms resistor is connected where? To the B node. You don't consider this voltage source. Any of this voltage source will be present between these two nodes, but this 3 ohms resistor is connected in the A node or first node and in the B node or in the second node. So the common resistor, that will be minus 1 by 3. This is very important, right? Minus 1 by 3. And you see 2 1. So second node and first node, what is the common resistance? And this will be same that we have already seen. Then this B node or second node, G22. G22, 1 by 3 is connected, 1 by 4 is connected, 1 by 5 is connected. So what you will get this one? 1 by 3 plus 1 by 4 plus 1 by 5. That's all. This is the G matrix that we have found. And what is this? VAO and VBO are the unknowns we need to find. We don't know, yet we don't know this. See, this current is very important here. How to write the current expressions? For that, what you do, you draw the current directions. Always you draw you see how many branches are available here in A node. This is one branch, this is one branch, this is a second branch, and this is third branch. You need to find what is the current in all the branches and what is the direction of the current. And always the current direction should be from minus to plus. You assume the current direction from minus to plus. See, I will draw here from minus to plus, right? Towards the node. Towards the node, you just draw the current value. from minus to plus. And what is the current? Current, which is nothing but V by R. What is V here? 10 volt. What is R here? 2. V by, that means 10 by 2, you will get what? 5 amperes. 5 amperes. And you see there is no current here. There is no voltage. So you cannot find the current. So you don't draw any current directions here. Not necessary. And you see here from minus to plus. If I draw from minus to plus, right? From minus to plus, what is the current value? 1 by 0.33. So what you will get? 1 by 3 will be 0.33 amperes. And now you see, you come here, right? That's all, right? I1, only I1. So there are 3 branches. I have drawn the current directions. Now you see, if the current is coming towards the node, you write that current in plus. If the current is leaving the node, then you write that current in minus. Here in the place of IA, right? So I will write this. See, 5 amperes is coming towards the node as well as 0.3 amperes also coming towards the node. So what you will get? 5 plus 0.33, right? That is the current value. That is the current value. That's all. This branch don't have any current. And you come to node B now. Node B, right? Node B. In node B, I've written this current value already. This branch current, and I want to write this branch current now. So current should be from minus to plus, this current direction, and 2 divided by 4, you will get what? 0.5 amperes. That's all. And if you want to draw the current direction for this, what you will get? This should be like this, right? This should be like this, from minus to plus, right? 3 divided by 5 you will get. So you will get 0.6 amperes. That's all. Now you see 5 amperes, 0.5 is coming towards the node, 0.6 is also coming towards the node, but this 0.33 is going away. So how will you write this one here? See, 0.5 is coming towards the node, so that should be in positive, and 0.6 is also coming towards the node, that should be positive, but the 0.33 is going away, so that should be written in minus value, right? So now you just try to simplify this expression and you write this. What I will get? I will write here. So I have simplified these values and I am getting this matrix now. So now you see, it is very simple to find what is VO and what is VBO. What we can do, we can write this as expression now, right? So this can be written as expression can be written as what? Simple. How can we write? So 1.83 VAO minus 0.33 VBO should be equal to what? 5.33, right? So this is expression number 1. So this row with this column should be equal to what? 5.33. And if you want to write what is this value? Minus 0.33 VAO plus 0.78 VBO, that should be equal to what? 0.77. This is expression number 2. So this row with this column should be equal to what? 0.77, right? So now you can easily simplify this expression and you get what is VO and what is VBO. And you see, I have got VAO and VBO from this expression. By solving this expression, you will get VAO is equal to 3.34 and VBO is equal to 2.40, right? So this is the VAO value and VBO value, and I will tell you how to find what is the current in each resistor with these two values, right? So what we have done, I will just summarize this because this is a new topic and this is a new learning to you. So what we have done, we have taken a problem and we try to solve this problem using nodal voltage analysis method. And first of all, you need to know how many nodes are there in the given problem. There are 2 nodes. Now I have told you, don't say this reference node as a separate node. So 2 nodes. So if you have 2 nodes, then you need to write the matrix form for 2 cross 2 matrix for G, and this V will be 1 cross 2 and this I will be also 1 cross 2. Okay, we have taken the two nodes and we have written the matrix form. That is, this is 2 cross 2 matrix, and this will be 1 cross 2, and this will be 1 cross 2. This I matrix and V matrix, right? This is very simple to write. G matrix is very simple to write. That what are all the resistors connected in node 1, that will be G11, and G12 will be common resistance between node 1 and 2, and G21 is common resistance again between 1 and 2, and this G22 will be what are all the resistors connected in the second node or B node, that we have taken the values of the resistors in inverse. Why? Because this is the resistor value, but we need what? Conductance value. That is why we have taken the resistors in inverse values, right? Then this VO and VBO will be the unknown parameters, and we need to find what is IA and IB. For that, to find IA, we have drawn the current directions in each branches. If we have voltage sources, then what we have done, we have drawn the current directions, and we try to write what are all the current coming towards the node, that will be considered in positive values, and what are all the currents going away from the particular node will be calculated in negative values. Then we have simplified this. Then we have simplified and we have made the matrix to simple form. So this simple form can be expanded to the expression that we have already learned. So we have expanded it and we have found what is VO and what is VBO. Now we know what is the voltage at this node with respect to O node, that is nothing but it is 3.34 volt. And what is the voltage at this node with respect to O node, that is nothing but it will be 2.40 volt. Right. We will see how to find what is the current in each resistor in the next class. Right. Thank you. You try to learn this. Try to go through this thoroughly. Then only you will get knowledge. If you know this, then it will be very simple to solve any problems. Right. Thank you. We will see in the next class.